Principles of Operating Systems, Chapter 9, Networks and Operating Systems. A computer network is a collection of computing devices connected using some communication medium. The devices are called nodes for the network. Now, every one of the computing devices, to be a computing device, it needs an operating system of some kind. And the network, a computer network as a whole, also needs some kind of a computer operating system. A network operating system, network OS, is system software that controls the devices on a network and facilitates the communication of one device with another. A network operating system is software application that gives us a platform for the functionality of individual computers and multiple computers within an interconnected system, a network. Basically, a network operating system controls the software and computer hardware on a network. It lets the software and hardware work on a network, is run network-oriented applications and share resources. The network operating system protects data and facilitates the communication. Individual computers then each have their client operating systems, and the network system as a whole creates the software infrastructure necessary for the network to function as a network. Some of the tasks that a network operating system has to deal with are pretty much the same as those of any other standard operating system. Memory management, hardware control, just two of those any kind of an operating system is going to have to deal with. Network operating system, though, have to deal with network things that a computer operating system would not deal with. Printers and disk drives have to be controlled and interfaced with the network. Network security, network administration are, of course, not built into a normal computer operating system. Those are network functions. And multiple users very commonly attempt to access network resources simultaneously, and this has to be controlled, dealt with to avoid problems. Operating system software is not restricted to what we traditionally think of as computers. Smart devices like smartphones, tablets, network routers, many other devices have built-in operating systems. Pretty much expected that a computing device is going to have the capacity for communicating and interacting with other computing devices. Mobile devices are expected to be able to communicate with networks, access the internet just about anywhere they happen to find themselves. Communication is an expected capability in the modern computer, and any modern operating system is expected to be able to deal with computer networks. A network operating system supports the basic operating features of a network, including support for the various protocols that allow the computers to share data. Many operating systems, network operating systems, automatically detect hardware within the system, which allows for asset discovery within the network. So you can add a new computer, a new device to the network, and it will discover it, detect it, and add it automatically. A network operating system also supports the processing of other software applications that can run on not only individual computers, but also combination throughout the network. There are a lot of different ways that you can configure a computer network, but almost all of them falls into one of three general classifications or topologies: bus topology, star topology, and ring topology. Of course, the topology is set up, configured, supported, and implemented by the operating systems on each of the nodes in the network. In a network configured with the bus topology, all of the devices, all of the nodes, share a common communication medium, the bus. In a bus network, every node receives or sees all of the network traffic. It's the responsibility of each node and the operating system on each of the nodes to identify which of the transmissions is directed to it and which should be ignored. In a network configured with the bus topology, it's possible, in fact common, that two of the nodes might attempt to transmit simultaneously. Now, most communication media do not support simultaneous communication. Using this non-simultaneous media, the operating systems have to use some kind of media access control. One of the common ones is CSMA-CD, Carrier Sense Multiple Access Collision Detection. This is what Ethernet uses to monitor traffic on the common communication medium. The bus topology has a number of advantages. One is that it is relatively quite easy to add a new node, a new computer or a new peripheral to a bus topology, or remove one. It works very well for small networks, a little more problematic for really large ones. The operating systems involved are relatively simple. They've been around for a while. They're well understood and well documented. And if one of the nodes fails, usually it's not going to affect the whole network, just that one node. There are, of course, some disadvantages to the bus topology as well. If you're implementing it using a physical cable connecting all of the nodes, as the earlier implementations did, then a simple break in the cable will shut down the entire network. Also, it does not scale well. If you have a lot of network traffic, as is likely if you have a large number of nodes, then there's a good chance of any attempted transmission resulting in a collision. And this then is going to end up resulting in a slow communication system, even some communication failures. The simplicity of the bus topology makes it the most popular configuration for home and small business installations. But as it doesn't scale up well, larger commercial installations are more likely to use the star topology. As the name implies, the earlier bus network installations used a single physical cable that connected all of the nodes. Modern installations tend to use Wi-Fi and do not have a physical connection, at least with most of the nodes. Wi-Fi network installations do not have the problem of being shut down by a single broken cable, although it's possible for a node to malfunction by continually broadcasting, and that would have much the same effect. But Wi-Fi networks do have the same scaling problems as physical connection networks. Since only one unit can transmit at a time, increasing the number of nodes increases the amount of communication, which increases the collision rate, slowing communication. In networks with a star topology, there's one central node or hub, and all of the other nodes, the peripheral nodes, are connected to that hub, that central node. Communication between any of the peripheral nodes has to be transferred by the central node. Communicate from one through the central node to another. All the traffic in the star network passes through the central hub, which acts as a signal repeater. The very earliest networks used the star topology. They did it, implemented it using a single computer, generally a mainframe, as the central hub, and the terminals were teletypes. Those peripheral nodes were teletype terminals. Later, as equipment on the peripheral nodes became more sophisticated, upgraded to personal computers, to workstations, to smartphones, and so on, the central hubs became more specialized. Some of the central hubs were switches. They were simply a device to transfer information through from one peripheral to another. Those units are very, very fast, but don't provide much, if anything, in the way of control or monitoring. Also, routers, whose function is to provide communication between the nodes on the network and other networks. Database servers, providing storage capacities and specialized capabilities related to databases, and others. The star topology is the easiest topology to design and implement. One of the biggest advantages is that it's easy to add or remove a node. And the fact that all the communications has to pass through a central location makes it easier to implement lots of security features. The biggest disadvantage of the star topology is that the hub is a single point of failure. Since all of the communication has to flow through that central hub, the aggregate bandwidth can form a big bottleneck for big systems, since it can't communicate any faster than the central hub. In a ring topology, each node is connected to two other nodes, and the collection of interconnections is a closed loop. Data travels in one direction. When a node sends a message to another, the message has to travel through each, has to be retransmitted through each of the nodes intermediate to. A ring topology is particularly good for busy networks. It completely avoids collisions between communications, and it's a simple system to implement. On the other hand, data transmission is subject to delay because a message has to travel through each intermediate node. It has to be retransmitted several times before it gets to its intended target. And the network transmission speed is no better than the slowest link, since your message has to go through the slowest link. And if any node fails, then the entire network stops working. As we mentioned earlier, some of the tasks of a network operating system are very similar to the operating system tasks for standard computers, memory management, hardware control, But network operating systems also have specialized tasks directed at network functions, control of access to network devices, printers, disk drives, shared devices on the network. And they also have specialized network functions, network security, network administration, and control of access for multiple concurrent users. Most operating systems used for individual computers do have built-in network functions, but there are also a number of operating systems designed specifically to be network operating systems. Linux, Mac OS X server, Novell, Windows Server are some examples. A network operating system is the platform on which computer networking operations take place. The basic networking features allow for connections for the file, print, and internet, control of data backup and replication, management of connection systems for networks, local and wide area networks, LANs and WANs. Now, again, any modern operating system is going to contain built-in software to support networking of computers. Typical operating system software includes implementation of TCP/IP protocol stack and related utility programs, ping and traceroute, for example. It also going to include device drivers and other software to enable Ethernet and wireless interfaces. Operating systems for mobile devices typically provide programs to enable Wi-Fi, Bluetooth, and other wireless connectivity. Some of the common tasks associated with network operating systems include user administration, system maintenance activities, tasks associated with file management, security monitoring on the resources in the network. The features of a network operating system include the basic operating system features, security features, features for file management and web services, and user management features, along with provisions for remote management, remote access, and permitting remote system management. Our basic operating systems, of course, include protocol support, processor support, hardware detection, and multiprocessing support, allowing applications to deal with multiprocessing. The security features, of course, involve authentication, restrictions, authorizations, and control of access.